Okay, Chapter 6, page 5, normal probability distribution, finding the cumulative area under the standard curve. Because the normal distribution is continuous, there's no area under the curve exactly specific to z. The probability that z lies in an interval is given by the area under the standard normal curve above the interval. For example, z is greater than or equal to 1.15 refers to the probability that the z values lie to the right of 1.15, so we just use z is greater than 1.15, okay? So what are we talking about? We're talking about this table here, table E. We use it to find the cumulative area. Remember, the area is this shaded part, okay? So if we have a z-score that's up here, and the area this way, we want to know what the probability is of getting a score from here over to the left. We want to use this table to find it. If your instructor allows other technical aids, please follow their directions, but I'm just going to stick with how to use the paper table, okay? The area is always positive when using the table, even if the value is negative. Think of this space here. There's so much space here. It's this much. It's a positive number. It's like distance. It's always positive, okay? So how to use the table. Get rid of some of this stuff. All right, let's look at the table for a second. Okay, here's a version of a table. There's a lot of different looking tables out there. This is one that's, instead of uploading your card that came with your book with all the formulas and all that, I just found a separate negative table. So it has a little kind of this extra dot stuff here that you don't really need, but I was just trying to show you what it looks like here. So it doesn't say E, but the one you have is E, okay? But it's a positive and a negative table. Here's a positive one, here's a negative one, okay? These are the z-scores here and here, okay? So if you were looking for, say, you had a z-score of negative 295, so you go down to negative 29, and you go over to where 5 comes down, and right there is the area to the left of 295, okay? So this area right here. If this was a z-score of negative 2.95, then the area or probability of a score being right in there is 0.0016 or 0.16% chance that it would fall in that area, okay? So I'm going to referring this to this. The positive scores look the same. We have positive numbers down this way and across that way. All right, so to find an area, you draw a normal distribution curve and shade the area under consideration. I like the little picture. See at the top of the picture, it had that little curve. So let's go to the first one here. I draw kind of a bad looking curve. Don't worry about that part. Remember, z-scores on the scale always have a 0 here. 1, 2, 3 standard deviations. 1, 2, 3 standard deviations. All right, so a score of 1.32 is what? Approximately in here somewhere. 1.32. And it says to the left. That means all of this over here. We are looking for the area, which I call a P number. You can call it, for probability, you can call it the area, whatever you want to say. And I need to look it up on the table, okay? So an area that's to the left of the value, you want to go to the E table and find the given area. So notice that this is a positive 132. So, oops, I'm going to go here, sorry, positive 1.32. So I'm going down here till I get 1.3. All right, and then I'm going to go over to 2, and right there is 0.9066. 0.9066. I went to the positive z table, went down to 1.3, and went over to 0.02, and the number that was there was 0.9066. That makes sense. If you these are kind of a little more like this. I just never have enough room to do all that. That's 0. So 1.3 is 232 is kind of like right there. And so this looks about 90% of the area is filled in from here over to the left. Okay, 90%. This is 90.66%. Okay. But if you have an area to the right, it gets just a little more complicated because remember it's set up there that the values are to the left. So if you want to the right of this, so right, I don't know, wild guess, like there, this, don't worry about the accuracy of your drawing, but know that the negative numbers are to the left, right? So you got to put 0.67 down here, but then it says you're shaded to the right. So this is all this in here, and we want to know how much area, which I, as a habit, call probability of your score being up here, is this whole area up here to the right. Okay, so to the right, you're going to find the z-value in the table and subtract it from 1. Okay, because basically you're looking up this area in the table, and when you subtract it from 1, you'll get this side, okay, because the whole area equals 1. So let's go to the negative table, because this is a negative 0.67. That's not how we get there. We go this way and then this way, and we look in the negatives all the way down to 0, right here. There's 0.6. And we're going across to a 7. Where's the 7? 7. It starts with a 0. So if you're counting over, it's 0, 1, 2, 3, 4, 5, 6, 7. Because there's only 9, right? So that would be here. Just to double check, go straight up. Yep, that's a 7. So negative 0.67 is 0.2514. 0.2514. So 1 minus 0.2514 equals 0.7486. So this is 0.7486. That makes sense. Remember, from the 0 this way is 0.5. So if we're going a little farther than that, I needed a number larger than 0.5. So 0.7486 sounds right. If you put in there that it's 0.2514, it's going to be wrong because that would be less than half, right? So it just wouldn't seem right. So make sure your answer is reasonable, okay? But you can also have one that's between. So if we have, this is looking a little messy here. Let me get rid of some of this here. Okay. If we have one between, let's see, here's 0. Where is 1.45? Let's go there, 1.45. Because they're positive, they're on the right side of 0. And then 2.32 is farther to the right, okay? And then the shaded area is between. So right there is what I'm looking for. So it says for between, you want to find both the values and then subtract, because think about it. You're going to look for the 1.5 to get this one, and then this one right here is going to be from here over. So we're going to have to subtract this one away to get that one. So 1.45, I'm going to go on the positive table, I'm going to go down to 1.4. and then I'm going to go across to 0.05, and the number in the middle there is 9265, okay? And for 2.32, I'm going to go down to 2.3 and over to 0.02, and the number I'm going to get is 0.9898. Remember, that one's pretty far over here, so this whole thing, if this was all the way to the right, I'd have that much. All right, and if this was all the way, all the way to the left. If this was all the way to the left, this would be 0.9265. But I want to get this area here. So it's going to be 0.9898 minus 0.9265 is going to give you 0.0633. Okay, so it seems like a little area. So remember, this is supposed to be a lot taller, and one of them is kind of like here and over. The other one is kind of like here and over. So this little spot right here is going to be 0.0633, or about 6% of the area. Okay?